You're welcome to the course on development and standardization of questionnaire, which is an example of psychological instrument. In this particular lesson, we'll be emphasizing how to standardize the questionnaire with focus on reliability. The psychometric reliability is one of the psychometric properties of psychological instrument. And in this example, in this particular case, we'd focus on the questionnaire. So you need to understand the concept of reliability and how do you establish reliability. There's a link of, the process is also linked with application of statistics also, because there's no way you can establish reliability and validity without using some statistical tools to establish the constructs. So we'll be exploring all this in the next few minutes. And this is actually what makes your questionnaire standard, because most people out there, and most undergraduates and graduate students in universities, even in most organizations using questionnaire, they hardly pay attention to the sensitivity of this issue of reliability and validity. And the implication is so terrible because at the end of the day, if you don't establish reliability and validity of your questionnaire or instrument you are using to collect your data, you discover at the end of the day, the information you've collected is not actually reliable, it's not valid, and that may lead to colossal waste in terms of time, in terms of money, and even in terms of life. And ultimately, the development of the nation may be at stake, or the organization you are researching, conducting research for based on the data you are collecting, because you are likely to end up with garbage information, and which leads to the syndrome of garbage in, garbage out. And that has been the bane of poor development in most developing nations, because people in these countries hardly do it right. And that is part of what we are how to correct, by presenting and making public this kind of lecture course or a short course on how to develop questionnaire. I'm hoping and trusting that as you get it right, you'll be one of those who will begin to contribute to the development of your community, of your organization, and ultimately your nation, by the grace of God. So let's now quickly proceed. Having established this fact, the next point you need to understand, what is the objective for this particular lesson? At the end of this lesson, you should be able to establish the reliability of a questionnaire. And this is actually what makes you a professional, and not a quack, as it were. I know this is what distinguishes quacks from professionals. When you are able to know how to develop reliable and valid measuring instrument or psychological instrument or question, with focus in this case on the questionnaire, and then you know how to interpret result to collect valid data that can now bring about reliable or useful decision that can move your country, your organization, and your community forward. So it's very important that I also mention the fact that the place of the pilot test in this exercise, an essential step for deriving the reliability of a questionnaire or any psychological instrument for that matter, is the need to conduct pilot test. It is from the pilot test, actually pilot test is just the administration of the psychological instrument you established. Don't forget, if you have been following the progression we have been taking now, but at this point, I'm expecting that you have already established the content and face validity of your instrument before you set out for pilot test, because that is very important. Before you set out to conducting pilot test, it is imperative you establish the content and face validity of your instrument. We explained that in the last series of last lecture. If you missed that lecture, I advise you to go over it again and make sure that your instrument meets the condition of content and face validity. You need to understand the meaning of those constructs and how to establish them. When your instrument have met those two vital conditions, that's when you are now set for the pilot study. And so you will not end up, in fact, the degree of having to go back to the drawing board will be minimized if you go through the content and face validity very well. There will be little or no need for you to start going back to the drawing board to start reconstructing or developing your questionnaire all over again, or your psychological instrument. And that is why I advise that you don't skip that step. Make sure you go through it and do it professionally as I've advised you in the course of these lectures. So your pilot study is in the process of administering the psychological instrument, which I believe you have established to contain and face validity. You now administer that instrument, or the questionnaire in this case, to a well-sampled population. I need to emphasize this. It has to be a well-sampled population. Your population must be well-sampled. What do I mean by that? Your population should be representative of your target audience. It should be representative of your target audience, and it should be randomly sector. The issue of random in any scientific study, randomization is so critical. So your sample should be representative of the larger population and of the target audience you are interested in, and it should be randomly selected. By just obeying the rule of randomization, you are likely to eliminate a lot of extraneous variables that are likely to pollute or affect the study or the data analysis exercise you are conducting. The measurement you are trying to conduct is not likely to be polluted if you engage randomization, because randomization have a way of canceling out all those random errors that are likely to occur. That's why we encourage that you employ random sampling as much as possible, not armchair speculation, not accidental sampling, not not convenient sampling. Those ones will not help you if you really want to conduct a proper scientific study. So having assumed that you've done that, then you can now go ahead, after obtaining the data, the data you now subject it to statistical analysis, and from that statistical analysis, you can now establish the reliability of the instrument. That is what this process is all about. So what exactly is reliability? According to Nunali, this is one of the authorities in the field of psychometrics, 1978 and 1994. He defined reliability as the stability, another word for stability is consistency, of measurement over a variety of conditions in which basically the same result is obtained. And it's a very simple illustration. It's just about consistency. And one of the illustrations I normally use in this situation is you step on the weighing machine, you step down again, you have not gone for fasting, you step on it again. And maybe the first time you stepped on it, it gives you 72, like my own weight is 72 kg. You step down, you step in again, and then it now gives you 84 kg by the next time you step in. And I'm not gone on fasting, or I'm not engaged in taking a load of chocolate, thereabout. And then I step down again, I step on it again in the next few minutes. And this time around, it's giving me 64 kg. Definitely, you can see that result is not consistent. Something definitely is wrong with that measuring tool, And, we're using that illustration in place of questionnaire. So questionnaire can also behave like that. When you see questionnaire behaving like that, that means it's not reliable. It's giving you inconsistent scores about the same person, who has not undergone any, treatment whatsoever under the same condition. You assess the person and the result is becoming spurious and is coming in different shades. In that situation, you discover that you will not be able to use that data, that information is likely to be unreliable, and it will not be useful for your intended purpose. And that is why it is very important that you establish validity, reliability. Now, I will settle this. I also need to mention the fact that you need to also understand the concept of errors of measurement. Now, the data obtained from behavioral sciences in most cases are often prone to errors of measurement. Unlike, like I've said before, the instruments used for collecting data in the physical sciences have been calibrated from the industry. Your ruler, your vernier caliper, your thermometer. So you don't really have any challenge with this, because there's no way the object you are trying to measure can start shifting from one place to the other. But human beings, they are so nebulous and fluidish. So you can pin them down. So you need more rigorous professional techniques of conducting measurement of those behavioral or psychological traits. And that is why we have to go through all this rigor. So you need to understand the concept of errors of measurement there, because measurements in behavioral sciences, in humanities, they are usually prone to a lot of errors, measurement errors. And basically, there are two kinds of errors, as pointed out by Rosenthal and Rosnow, and they are systematic errors and random errors. So what is the difference? Systematic errors, when it comes to a good illustration of systematic error is the use again of the Bertram scale, weighing scale. Now, systematic errors could be at play, for instance, when you repeatedly weigh 10 kg higher than your actual weight due to calibration error. Maybe ideally, like I said, my own weight is 72. And every time I step on that weighing machine, it's giving me 82 kg. And I know that I'm 72, but this particular weighing machine is consistently giving me 82 kg. By the time I step out and I use another weighing machine, I have the correct measurement of 72. So that shows that that particular Bertram weighing scale at that point in time was wrongly calibrated, 10 kg above the normal or ideal weight. And that is a kind of systematic error in itself. So there are some instruments like that in the psychological domain, even including question, that can give you that kind of measurement. So we always try to avoid this kind of error. We don't want systematic error. It's not good. So this shows that, of course, in this case, now, the average of this cannot cancel out, no matter how, it will just keep on having that error. So it gives an erroneous impression about the measurement of that being released from that particular weighing instrument. It gives erroneous impression that the person is overweight, when the person is not. So systematic error like this is of major concern in the field of psychometrics. We are weary of this kind of error. We don't want systematic error at all because it's very, very misleading. It could be very misleading. And of course, by extension, it affects the validity of the instrument. So it's not only the issue of reliability now, because once your reliability is at fault or is faulty, it's not in place, it will automatically affect the validity of the instrument also. And the bottom line of all this is that once your instrument is not valid or it's not reliable, that means that the data you are going to get out of use of such instrument, be it questionnaire, be it any other psychological scale you are out there using, intelligence test, personality test, or whatever kind of questionnaire you're using, the information or data you are getting from the use of such measuring tool will not be reliable. And so you end up with garbage in, garbage out syndrome. So whatever decision you try to make out of that using such information will be misleading and can actually be very disastrous. So that's why the second kind of error, of course, is the random error, which has to do with, for instance, random error will be at work if your scale was correctly calibrated, but somehow the person, maybe because of the angle with which you are looking at the measuring scale, you kept on adding some few, kilograms or grams to the measurement because your eye slant was not properly placed, or maybe the particular angle you are conducting the measurement. It could even be because even the person is having a kind of visual a deformity. So it could also lead to it. So many other factors could lead to random error, actually. It could be because you are dizzy at that point in time, or something just happened, or you are distracted, so you could misread the weighing scale and have a slightly different measurement. And this could occur for as many measurements as you are as occurring. So consequently, on such occasions, you will read your weight as being slightly higher, or on some occasions has been slightly lower than it actually was. So this is what we call random error. But the interesting about random error is that by the time you conduct such measurements over a large pool of people, it will naturally cancel out. And because the central limit theorem will begin to apply, and then you discover that the larger the number, the errors, will be plus, minus, plus, minus, plus, minus. By the time you add all those errors together, they will naturally just cancel out. So psychometricians are not too disturbed with random error because it's natural, it's human that you commit some slight errors when you're conducting measurement around there. But as long as it's random error, it's not systematic error, we believe strongly that they will cancel out and the effect will be negligent and will not even be registered, as it were, in the long run, as it were, especially when you have a large sample size, as it were. So the effect will be minimal on the overall result. So take note of this when you are conducting your measurement and check whether you have systematic error or random error. If it's systematic error, you find a way to correct it from the onset. For random errors, we still try to reduce the random errors as much as possible, but it can hardly be totally wiped out. But the good news about random errors is that when you have a large sample of measurement, it will naturally cancel out, and it will not be anything you need to worry about. Of course, in the course of statistical analysis, some of these errors have been factored into the measurement also, and that is part of the reason why we use the probability factor, which is the P factor. That is, if we don't allow for probability of more than 5% of error, we go for 95% confidence interval. So we have made room for that error, that issue. For most social scientific studies, the error should not be more than 5%. So this kind of random errors have been factored into that particular statistical analysis. And that is the beauty of that also. So with all that in place, you now begin to see how the professionality, when we are conducting measurement in the social sciences, and how we want to make sure, because this is the bane, like I said at the beginning, in the intro to this course, the bane of scientific study that will lead to witty invention is accurate measurement. So you don't be too tired about making sure you establish the reliability and validity of your instrument, your measuring instrument. We're only using questionnaire as a case study in this course. There are so many other formats of instruments, which I've mentioned at the introductory stage also, including achievement tests, aptitude tests. They're all various forms of shades, inventories, and so on and so forth that we use to collect information or data in the behavioral sciences and in the humanities. And the common line for all of them is that because we are engaging, we are seeing ourselves as scientists, we must make sure we engage accurate measurement. And that accurate measurement is determined largely by establishing the reliability and validity of the instrument. And that's the process. So you can see this particular lesson beginning with this next two lessons on reliability and validity as one of the cornerstones of what makes for scientific study in the social sciences, especially when it comes to the use of developing questions. The point is that many of our undergraduates, they don't even have time. They have not been taken through this kind of lesson to even begin to even realize that it's necessary for them to establish the reliability and validity of their questionnaire. Many of them were not taught. They did not even see it as very necessary or significant. Many people just sit there and then just conjure the items, and you can see the process. Before you can develop items, you see the lesson on how to develop the content of your questionnaire. You need to go through that again. You discover that you can't just sit down and just begin to conjure statements from your head and just put it down on a sheet of paper and then begin to slap people with questionnaires and say you have developed questionnaire. Man, that would be a mockery of the academia. It would be a mockery of the scientific study. That can be a scientific study. And that is why we are not having we are not seeing the kind of result we're supposed to be having, because we are not following the proper scientific procedure. And this is what makes it so. The process of establishing the reliability and validity of your psychological instrument, we call this, and these are actually what we call the psychometric properties of the questionnaire, or psychometric properties of those psychological instruments for collecting data. And that is what brings us close to what the real scientific measurement and scientific process that we give back to witty inventions that we are actually aspiring for. So what are the types of reliability we need to focus? We're going to be focusing on in this particular study. We're going to be focusing on 3 types of reliability estimates. One of them is test-retest reliability. Another one is parallel test reliability. And then we have the internal consistency reliabilities. The last one, they have more than one in that category. We have the one established by Cronbach Alpha, and then we also have the split half internal consistency. We're going to be discussing that. So in all, actually, there are about 4, but 2 under internal consistency. So we're going to be doing an exploration of all these. It's the same thing. That's just a graphic illustration of what we're going to be exploring in this particular lesson. So let's start with the test-retest reliability. As the name suggests, the idea is simply to administer the same test to the same set of testings under the same condition after a time interval of about 2 weeks or more. Simple. Test and retest. The same instrument. And of course, this is the assumption that the test is not susceptible to test familiarity. Because once your respondents are familiar to the test, it can affect, especially if it's an achievement test, it's likely to affect the results you get. But if it's not an achievement, it's just a simple questionnaire, and you did not warn them that you are coming back again, you are likely to get a very good result out of it. It's going to confirm indeed whether your instrument is consistent or not. So you administer the instrument to them, you go and score, you got the score, then you administer it the second time again. And by the time you do the second administration, and this is very important, so this course of tests is in both rounds, of the 2 rounds of tests you have conducted, you now apply. Now listen to this. When it comes to test retest, the statistics you are going to apply is the Pearson product moment correlation coefficient, because you are trying to establish the correlation between the 2 sets of scores. Of course, there are many kinds of correlation coefficients, but when it comes to data coming from test retest, because we see this data as falling under the interval and ratio scale, as it were. That is why it falls under the parametric correlation coefficient statistics, and PPMCC is a parametric correlation coefficient. The non-parametric versions of the correlation coefficients are Spearman-Rome, Crumbach alpha, and so on and so forth. That is why you have that difference. So in this case, you use the parametric correlation coefficient, and the popular one there is the Pearson product correlation coefficient, popularly. I mean, the acronym, of course, is PPMCC. Of course, you see this in the SPSS, Statistical Package for Social Sciences, a popular statistical package that is used. They are all available there that you can easily use. And one very popular thing, of course, the result is always ranging between 0 and 1 plus or minus. And so if you have if you have a score of, R value of maybe 0.92, that suggests that your instrument has high positive correlation coefficient. And that suggests that the instrument has strong reliability. The closer to 1, the higher the reliability, especially when it's positive. But when it's negative or near 0, that's suggesting that that instrument is not reliable. That is, the degree of consistency between the 2 sets of scores is very low. So you need to go and check it. Why is it so? Are you sure it's the same instruments? Or maybe it could also be because, of course, your respondents, they are not properly motivated and they're just giving you a nonsense response. But if you have assured yourself that you have properly motivated them, you have encouraged them to give factual response, and you discover that the consistency will be definitely high. And that's what the term is. Or else, if after motivating them and you have encouraged them to respond factually and you are still not getting high correlation, that simply means that that instrument, you need to go and review it and check the content validity again. And of course, the face validity. Maybe something actually is wrong. Perhaps just your respondents are not understanding what you are saying. Maybe there are ambiguous questions there that is just confusing them. And so they are not giving the same response. They're just guessing, as it were. So those are the things you need to go and check. And that is the essence of actually undergoing this kind of study on reliability, to be sure that your instrument or the questionnaire is actually giving you consistent measurement, giving you the same set of results, as it were, concerning your respondents. That is the essence of this. Is this same interpretation I've given you concerning correlation coefficient, because for most of the reliabilities is actually correlation coefficient correlation coefficient to be using. So whether parametric or non-parametric, this is the same range of between 0 and 1, the same range of plus or minus. And this is the same interpretation you actually use to conclude on all of them, as it were. So the only difference may be that you are not using PPMC in some cases. In some cases, you are using Spearman-Brown prophecy formula, or you are using Crumbach alpha. But whether Crumbach alpha, whether Spearman-Brown prophecy formula or PPMC, the range is still from 0 to 1 plus or minus. And the closer to, plus 1, you are getting the more positive and better the correlation, which is signifying the degree of consistency of those scores. And the farther away you are from 1, and the closer to 0, if your result is negative, that is suggesting that your reliability is questionable, and you need to go back. You may need to go back to the drawing board and check what is really causing that. That instrument may not be. It may not be wise to go ahead to use such instruments without correcting the error there until you get a reliable measurement. Is very important. So that is that about that. Then still talking Now we want to move on to that one is the test retest. Now we are moving on to the parallel test reliability. Now the parallel test reliability is used to assess the consistency of results of two tests constructed in the same way and from the same content domain. This is also called alternate form reliability. For an achievement test, for instance, a true parallel test can be obtained after item analysis has been conducted. And item analysis, for instance, is checking for the degree of difficulty, the destructive index, and then the discriminatory index. But let's just focus on that difficulty index. When you know the difficulty index, it allows you to be able to select questions of the same difficulty across board. And that will allow you to have two set of questions of parallel difficulty, of almost the same difficulty. That is for achievement test or aptitude test anyway. But when it comes to personality instrument, an expert judgment is preferred to be you have to rely more on expert judgment when it comes to personality instruments or other kind of instruments like inventories, career inventories, opinion poll and things like that. Others kind of survey, you may need to use expert judgment. And what you do in such situation is to allow the researcher should generate a large pool of items measuring the same construct. So let me use the example of personality test, for instance, that have 5 domains. So instead of generating just 5 questions now, you may decide to generate even up to 10 questions under each domain. We normally recommend between 3 to 5 for each instrument, because you want to split you want to have 2 parallel tests. So first of all, you generate like 10 questions under each of the domains of the 5 domains. I told you we have the acronym. The popular theory we use is the Big 5 theory, which has 5 domains. We have the openness, we have the conscientiousness, we have the extroversion, we have the agreeableness, and then we have the neuroticism. So under each domain, originally I said you should just develop 5 questions, but this time we can develop 10 or 12 questions. And then if you do 12 for each domain, each of those domains, you can now randomly, you just give them number, put the number in a box somewhere, and just randomly just select questions. You put one here, you put another one here, you put one here, you put another one here. By that random selection, you are likely to have 2 parallel tests at the end of the day. So that is one way. You can also use expert judgments to do the selection into 2. They are looking at it, they're not even applying random judgment. They are looking at it and comparing the content of each statement, and they use that to create 2 parallel tests. These are various techniques you can use to create parallel tests, even for personality tests. So once you have a large pool of questions, it becomes very easy for you to develop a parallel test. And the beauty about this is that once you have gotten the parallel test, then the next thing you just do is to administer the same test this time around. There's no time interval in this case like that of test retest. And that's the beauty of this, because this time around, your respondents is one time you just motivate them, and then they respond at once to the 2 sets of parallel tests, and then you collect responses back. But you are going to have 2 sets of scores for each respondent in this case at the same time. And then you are under the same conditions, of course. So every other thing will just flow into place. And for this case also, you are going to use the PPMCC, because it's almost following the same pattern as the test retest. So you use the PPMC to do, that is the Pearson product moment correlation coefficient. And of course, if your result is very close to 1 and is positive, that is an indication that your instrument is having a strong reliability. But if it's very low and getting close to 0, or you are having negative correlation coefficient, that is an indicator that the instrument is not reliable. It's not good for you to go ahead and use it. There's no way you can gloss over this. This is a scientific report or evidence you are getting that your instrument is not valid. So you need to go back to the drawing board and check what is wrong and correct it before you can go ahead. This way you will save yourself a lot of trouble. You will save your nation, your organization, a lot of waste if you just pay attention to these vital points that I'm sharing with you now. You don't gloss over them, and then you just don't go ahead and do it anyhow. This is how to become a true scientist in the social sciences, and not just, a quack, as it were. So, and the last set of reliability you can also use, which most people use at times because of time factor, whatever, but I don't subscribe to it. It's a form of laziness, and it does not actually support the spirit of the true consistency and reliability we are trying to check, because the truth is that internal consistency is not true reliability. True reliability is actually administering the test, two consecutive times and having the same consistent result, the same way you use the measuring scale. And the closest to that, of course, is the test, the parallel test. Those are the two that are fairly acceptable to be as far as concerned. When it comes to internal consistency, the focus of internal consistency is completely different. It's different. It's like the name suggests, it's just checking internal consistency. It's not checking for the consistency of the score over time. And that is the difference. And so it's a different ball game. It's having a different purpose, which is also useful, of course, because it's checking the internal consistency, and to some extent, it's also supporting the validity, of the instrument, as you're going to see later on. But I just wanted to understand that this is not true reliability, as it were. It's just internal consistency. So it's a measure of how the test in it, and how the items in his test measure the same construct according to Williams. So constantly the approach to establishing consistency is to correlate the values of responses to all the items within the test with the total score for all the items. Actually, that's the pattern with Cronbach alpha. Each item is correlated with one another and then with the total score. And then you see all these figures coming out at the end of the day in your result output. Of course, the primary goal of Cronbach alpha is to show the degree of cohesion or homogeneity. When we say homogeneity, the agreeableness of the items, to what extent the items are measuring the same construct. And that is actually what also leads to what we call factor analysis. So they are related, of course. So consequently, the statistical method shows that the items are not performing well and are likely to enhance the degree of internal consistency if deleted. So Cronbach alpha, the beauty of Cronbach alpha again is that it shows you the item that if you delete the item, it will enhance the internal consistency of that particular. It will enhance the internal consistency of that particular instrument. And so it's very important. Maybe along the line, another course, I'm going to actually show how to conduct some of this statistical analysis and how you see some of these results. In another lecture, I'm going to show some of the statistics, because psychometrics is never complete without statistics. You must have some basic understanding of statistics to be able to do well with your psychometric knowledge. And that is very important, of course. So that is what the Cronbach alpha vis-a-vis internal consistency will display to you. Now, of course, some schools of thought have questioned the effectiveness of Cronbach alpha, but the fact remains that when used in conjunction with related internal consistency reliabilities like factor analysis, it is still very useful tool in ascertaining the internal consistency of psychological instrument. Factor analysis is a very, very good one, because by the time you are doing exploratory factor analysis, and then confirmatory factor analysis, you begin to see the interplay and how that this analysis actually have a way of ascertaining the validity of the instrument you're actually measuring, because it's telling you that those factors, they're homogeneous and measuring the construct that you actually purport it to measure. And that is one of the spirit, of course, of validity. So you can see now that it's turning more towards validity than reliability, but we call it internal consistency, because it shows the degree of homogeneity or agreeableness or cohesion of the items constituting that instrument. That's why we use internal consistency reliability for it. So like I said, the real valid kind of reliabilities are the test retest, particularly is the most potent, then maybe followed by the parallel test. And then let me show you a final one, which can actually suffice for reliability too, but again, which has some little deficiencies. And that's why we don't use PPMC to analyze this one. Now, according to the APA, the APA defined split half reliability as a measure of internal consistency of surveys, of psychological tests, questionnaires, and other instruments or techniques that assess participant responses on a particular construct. So to them, it's a measure of internal consistency, or basically that is what it is, as you're going to see very soon. So it's another form of internal consistency, split half reliability. So what does it really mean? Split half reliability is determined by dividing the whole set of items. So if you have an items maybe from 1 to 20, so you can decide to pick the odd number items, separate them, then even numbered items, separate them. Of course, I expect that you will have arranged all the items sequentially and make sure that all the items are measuring under each domain, they are measuring the same construct. So on the basis of that, you do your selection and select equal number for each of the items. And you see, if you do it very well, it's almost going to actually appear like if you look at it, it's almost going to appear like the parallel test if it's done properly. But because this one, you are not actually planning to conduct a kind of, you are not trying to develop two parallel tests per se. You are still using the same instrument. It's actually during your analysis, you are going to have a single instrument which you are going to administer to people. It's during your analysis, you now pick the items for the odd items, I numbers. You add those one together. You now pick the responses for the even items. You add it together and you now correlate. So that's the difference with split half compared with parallel. Parallel, you are having two independent instruments which you are going to administer to your respondents at the same time. But split half, you are administering only one instrument to this respondent, but when it's doing your analysis, you will now separate the scores for the odd number items and then the scores for the even number items, and then do apply statistics on it. This time around, you can't use the PPMCC, the Pearson Product Numerical Correlation Coefficient. This time around, the statistics you are going to use is the Spearman-Brown prophecy formula. Now, that's a recommendation, even of the APA too. So that is the recommendation. And of course, the way you interpret the result is the same. If your result, again, your R value is close to 1 and is positive, that's an indication of high internal consistency by split half reliability. But if your score is near to 0 or negative, it's an indication that the instrument is lacking sufficient internal consistency by split half reliability. I hope you understand this. So these are the major forms of reliabilities, and you need to establish these reliabilities before you can proceed to using this instrument. Of course, reliability is not enough. You also need to establish the validity. Please understand that the questionnaire, like other psychological methods, is hardly truly standardized without the establishment of validity. Validity is a more, principal requirement for standardization of any psychological instrument than even the reliability. But of course, your validity, you cannot have even validity without reliability. So they're intertwined, and you need to understand all this. So validity is a more important requirement in standardization of psychological instrument, therefore. And so this will be further addressed in the next lesson as we're going to proceed. Thank you very much again for listening to me. See you again in the next